The irony of Africa is that for a few months of each year, the torrential rains transform the dry thorn scrub into a lush garden. Every dry riverbed becomes a rushing torrent and water is freely available. At this time of year, it is the quality, not the quantity of the water, which is the issue. But when the rain ceases, these impressive rivers quickly dry up. The water often subsides beneath the surface, where it has to be scooped for the rest of the year. Very often, the closest source of protected water is only 20 to 30 meters away, beneath our feet. However, the technical provision of clean water is relatively straightforward compared to the human factor. When a new water source is made available to a village, many issues arise. In order to succeed, project planners have to fit in with the seasons. There are times when no one is available to work on community projects. In the early years of the water decade, project planners imagined that the only assistance the community could offer the project would be the contribution of labor and providing local materials such as sand or water for building. Nowadays, however, it has been generally acknowledged that if the community are involved right from the initial planning stages, the project is more likely to receive their full support. Because of the nature of subsistent economies, change must be a slow and steady process. Project staff and local government officials must combine forces with village leaders and make sure that everyone is in agreement over the proposals long before the installation starts. Only once all these issues have been genuinely resolved and a committee formed to caretake the new installation can the planners move ahead with the project. Equally, once the community are ready and enthusiastic, it is important that the technical implementation is coordinated to take advantage of good timing. Community mobilization means not merely cooperation with the water project, but acceptance of the need for clean water. All this has to be resolved before the first stone is lifted. If the community preparation has been successful, village operation, maintenance and management of the new water supply should be a reality. At Kiagu, the community are waiting for the technicians to arrive. Before any concrete work begins, it is essential to establish where the runoff from the handpump will go. Do the people want a clothes washing facility? Is a bucket stand necessary? And is this an area where a cattle trough would be needed? Ngunjiri instructs the village laborers to dig a square pit around the borehole casing 500 millimeter deep. Others are shown how to mix the concrete. 1 part cement, 2 parts sand, 4 parts crushed stone. They mix it dry first and then add enough water to make it a stiff mix. Too much water will weaken the concrete and cause it to crack. Put a square mesh around the bars. Tie the mesh down at least 4 places on each side. The shorter side of the pedestal should face where the drain is going to be. Use a spirit level on the top to ensure that it is level. Paint a thin layer of used motor oil into the inside of the pedestal mold. Put the mold over the pedestal reinforcement. Make sure it is central and level. Cover the borehole opening with a blanking plate so that nothing gets dropped down. Pour in the concrete until the top of the mold. Leave 90 millimeter between the concrete and the flange. The concrete apron and drainage can be designed in any way. Excavate to a depth of at least 100 millimeter the area marked out. Pour the concrete into the pit and poke and tamp it to remove air. Level it up to the ground level. Wherever concrete is used, it is vital that it is properly cured if the hand pump is to last well. Every day, water must be poured over the concrete, and then it should be covered up again to keep it damp. The hand pump should not be fitted until the concrete pedestal and apron have been cured for a full week. Good drainage is the main concern, as standing water around the pump can contaminate the borehole. This design has an underground drain so that the spillage from the hand pump runs down to a cattle trough. In this area, water is found between 10 and 20 meters. The Afridev hand pump is recommended for lifting water from a depth of 10 to 45 meters and as such should be suitable in this area. During the drilling, the borehole was tested to find out what the yield of water was. This is called the test pump yield or quantity, QTP. In this case, it is 0.25 liters per second. The first thing that has to be established when equipping a borehole with a hand pump is how far down the cylinder should be placed. This is called the cylinder setting. To find the best position, the hand pumping water level, the HPWL, must first be found. This is the level to which the water will drop after continuous pumping has been taking place for some time. The exact length of time does not matter, as it reaches a certain level no matter how long the pumping continues. This difference in water levels is also known as the drawdown. First, find out the static water level, S. This is the same thing as the water table. It can be easily done by putting a dipper or a long length of plastic rope down the borehole and measuring the length of dry rope. At this borehole, it is 8.5 meters. Now we want to know how far the water level drops when pumping takes place. This is the pumping water level D and is found out during drilling and yield testing. In this case, it is 27.5 meters. The hand pump delivery rate, QHP, or in other words, the discharge of the hand pump during steady, continuous pumping of the Afridev hand pump is usually estimated at 0.33 liters per second. In fact, the rate that people usually pump will be lower than this as they change places, wash buckets, or take a short rest. Now we have all the information needed to find out the hand pumping water level. This is done by a simple formula. Hand pumping water level with drawdown equals S plus QHP into D minus S over QTP. According to our information, this is 8.5 plus 0.33 into 27.5 minus 8.5 over 0.25. The hand pumping water level, therefore, is 33.6 meters. The intake at the bottom of the suction pipe should be set between 4 to 10 meters below this level. Let's use 4.3 meters. So in this case, the intake at the bottom of the suction pipe would be at 37.9 meters. It is very important that the cylinder intake must be at least 1.5 meters above the bottom of the borehole. If it is too low, the sand will be sucked up and damage the hand pump. If there is no information on the various quantities because there have been no yield tests, then one can estimate from other wells in the area. This borehole is 42 meters deep, and so the cylinder is to be set at 37 meters. Having established how deep the cylinder will be, you can now lay out the required number of PVC pipes. These are the tools and equipment needed to install the hand pump. What is a rising main? A rising main is the PVC pipe through which the water is pumped up from the cylinder to the hand pump. Now take the sandpaper and lightly roughen all the edges of the pipes on the outside of the thin end and on the inside of the bell end. Now, this is the cylinder. It comes with a foot valve inside. To get the foot valve out, they provide you with this tool. We call it a fishing tool. It hooks the top of the foot valve and will only release it if you hold it horizontally. You must take out the plunger and the foot valve. It's always better to keep everything clean, so just wipe the ends of the cylinder with this fluid which has been provided. The suction pipe goes right at the bottom, below the cylinder, but it must not rest on the bottom of the borehole. They have provided these two holes so we can put the rope through to hold up the whole rising main. We know the cylinder is going to be 37 meters down, so we need twice that amount of rope plus an extra 4 meters. That makes 78 meters. It is easier to measure it in the open where we can pull the rope straight. Now you can see how deep the borehole will be into the earth. Tie a knot close to the pipe on both sides to stop it slipping. They also provide this solvent cement for joining all the PVC pipes. The two surfaces must be roughened up a bit. Now we put a thin coating on both ends which will stick together. Then push the cylinder straight into the suction pipe without turning it. Let it dry. It only takes 5 minutes to set. Then we do the top end of the cylinder where it joins the fast rising main pipe. Right, now this is the last pipe. Pass the steel cone and the rubber cone. They go on like this, the flat edges up. Put on a thin layer of solvent and fix the top sleeve flush with the pipe edge. Put the rope through the eyes on the steel con. Tighten the rope and knot it securely, and lower the whole rising main onto the pump pedestal. We'll just fasten the pump head on to protect the borehole. Tomorrow the solvent will be set and the rising main will be strong. Then we can install the Afridev hand pump. Right, it won't take long now. Hey, Fundi, can you tell me which one is the foot valve? Okay, as long as you don't put the wrong one down the hole. The foot valve has the small O-ring. We just check that it is all right. And the bobbin is in place, then you put it down the hole. Right. This is the plunger, and all the pump rods join onto it so that it can be pushed up and down to pump the water. We just check the seal is on the right way. Good. It has to have the groove facing upwards. Each rod has a centralizer to keep it in position. Now, bring all the rods and we'll connect them. Continue joining the rods until the last rod. Now we push the rods down as far as we can so that the foot valve is pushed into the receiver at the bottom of the cylinder. Leave the rods in the position and mark the top hanger rod 50 mm above the top face of the sleeve on the rising main pipe. Cover the rising main with some cloth so that no metal shavings go down the hole, and then cut the rod with a hacksaw. Now we clamp the hanger onto the rod end and tighten the bolt at the side. We can just lower the rods so they rest on the foot valve while we fix up the pump head. Take off the cover, hanger and handles. Place the pump head body on the pedestal. Put in the M16 bolts. Tighten the nuts with the spanner provided. Lift up the pump rods. Put the spanner through the hanger eye and then allow it to rest in the grooves provided at the top of the pump head. Take the two fulcrum bushes. They go on the fulcrum pin like this. Now we put the plastic bushes and hanger pin into the hanger housing. This is called a lug. You have to be careful here to find the lug on each bush and turn it round until it goes into this slot. We just lower the handle so the slot engages the hanger pin. This takes the weight of the rods off the spanner. Now we can take out the spanner and use it to tighten the nuts. These are the hanger nuts, and these are the fulcrum nuts. This is the part which must be adjusted for each hand pump depending how deep the water is and the cylinder setting. This is called the T-bar distance. The depth of the water from where the hand pump is pumping is called the pumping lift or pumping water level. Okay, now you put the cover on and tighten the nuts, and we are through.